At Pacific Northwest National Laboratory in Richland, Washington, over 6,000 staff tackle the world's toughest science and technology challenges in chemistry, earth sciences, biology, and data science. Scientists use supercomputers to tackle problems regular computers can't. A supercomputer splits data across thousands of processors working simultaneously, creating simulations, data analytics, or machine learning models to advance scientific discovery. Consumer hardware often lacks the power to complete these tasks in a reasonable time, or becomes unusable until the task is finished. Large labs address this by investing in supercomputers, allowing scientists to rent computational power or use interactive apps like VS Code, RStudio, or JupyterLab with complex datasets without overloading their personal computers. Users typically access supercomputers through Bash, a command line language that can be difficult for less technical users. To solve this, OSC developed Open On Demand, a web-based graphical user interface for accessing supercomputers. Our project was to redesign this GUI. We conducted usability testing, which revealed navigation and workflow issues. These insights shaped wireframes, which evolved into a high-fidelity prototype. After iterative refinements and UX testing, we delivered a coded prototype of the redesigned Open On Demand. And here is a walkthrough of the redesign we created. The first feature we added was favoriting, allowing users to keep the apps they use the most at the top. New notifications appear here, distinguishing user messages and admin announcements by color. Unread messages are flagged, and users can keep or delete notifications as they choose. Looking at the rest of the toolbar, we have added a drop-down for users to check on and navigate to their active jobs, and the OOD tools are kept in another drop-down. Let's check out the partition usage graph. We have designed pie charts to show the overall usage of each type of computing hardware and have added additional data for admin users. Below, we show the individual partitions and their percent used, along with overall active usage data. The job submission form is how users are able to set up jobs to run on the supercomputer. Info that is likely to be kept the same across jobs is stored in the top left, but includes pop-ups when making changes. Below is the package installer, a feature we designed after feedback was given that installing packages was confusing and caused issues for users. The next section is the job form. We redesigned the UI to feel more like a web page rather than a simple form, and we optimized the layout to use screen size more efficiently. We added graphical displays of the node usage and each partition's usage, giving the needed data to users at the time they need it most. Help buttons were added to explain the fields that require technical expertise. The job status form was completely redesigned to display more information while offering more options, including buttons for the directory, output log, and terminal. Graphs were added to illustrate the amount of computational power the users requested that is being used, helping them to get a better idea of how much compute is needed for future jobs. The last section included in this demo is the file manager, in which we redesigned the UI.